Hello guys, so this is my special once again. Welcome back to my channel. So today we'll be looking at Coulomb's law. Now before we go to Coulomb's law, I want to explain something called field. What is a field? A field is a region of space where the effect of that force can be felt. Now imagine I put a magnet here and I put a very metal here. You will see that the effect of this magnet will be felt on this metal. Why? Because of the metal will attract the magnet. Now I cannot say that a field is a region of space. This magnet is a field or region of space where the effect of this metal can be felt. Now if I now talk about electric field, an electric field is a region of space where the effect of electric force can be felt. What is magnetic field? A magnetic field is a region of space where the effect of the magnetic force can be felt. Are you getting my point now? Now if I want to define a Coulomb's law, Coulomb law states that the force experienced in an electric field. However, what is an electric field? An electric field is a region of space where the effect of electric force can be felt or experienced. Are you getting my point at all? Now, so I cannot say that what the force experienced in an electric field is directly proportional to the product of the charge of the charge and inversely proportional to the square of their distance apart. Again, the force experienced in an electric field is directly proportional to the product of the quantity of charge and inversely proportional to the square of their distance apart. That means now, to now introduce this constant, I will now say that my F is equal to what? KQ1 Q2 over R square, where my R is my distance, where my Q is what? Is my charge, is the quantity of charge, while this my K is our constant, and our value for K actually has a value, and K is equal to what? 9 times 10 is power 10, so it's power 9. This is Newton meter square per Coulomb square. So that's our unit for our constant K. So our first question: a 10 microcoulomb point charge is 25 centimeters away from a minus 20 microcoulomb point charge. Calculate the magnitude of the electric force between them. That means now, whenever you see a question that has to do with physics, the first thing is that what you have to analyze the question first and write as what your parameters. That means you have to calculate what the magnitude of the electric force. That means you are looking for what? Force F, right? Now, what do you know about this formula? The formula is what? Is F is equal to what? KQ1 Q2 over R square. Now, a 10 microcoulomb point is charged is 25 centimeters away. Now, let's assume that we have a coulomb here. We also have a coulomb here, right? Now, we have coulomb here, right? So, like, we now have this one represents the distance. I mean, the distance was 25 centimeters. Now, like, the first one was 10 microcoulomb. And this one was minus 20 microcoulomb. Remember, according to electrostatic force, it states that like charges repel, and unlike charges do attract. That means positive and positive they will repel. Boy and boy, they will repel. Girl and girl, they will repel. But boy and girl, they do what? They will attract. That is why this one is positive. Positive, we always do what? We always attract what? Negative. Are you getting the point at all? So now, we now have to calculate what? This force. Note that our constant K is what? Is 9 times 10 is power what? 9, right? Newton meter square per what? Per Coulomb square. So that means we are given our value for what? For our K directly. Now, what is our Q1? That is our Q1. What is our Q2? This is our Q2. Now, for our distance is what? Is centimeter. You have to convert it to what? To meter. And whenever you are converting to meter, you have to divide by what? By 100. That's what? Divided by 100. That's going to be what? 0.25 what? Meter, right? That means now, but I give you microcoulomb. One microcoulomb is equals what? 1 times 10 is what? Minus 6 coulomb. That is 1 micro. Like this one represents what? Our micro. Are you getting the point at all? That means what? That means I have to do what? I have to multiply my 10. 10 times 10 is what? Minus 6 coulomb. So the question is going to be what? It's going to be F is equal to everybody. What's our K? Our K is what? Is 9 times 10 is power 9 times. What's our Q1? Our Q1 is what? Is 10 times 10 is what? Minus 6 times what? Times minus 20 times 10 is what? minus 6. Now note, this negative that is here is just showing whether it is actually attracting or what, or so this negative here is actually showing whether they will do what, they will attract or they what. Now this negative charge here is just showing that whether they will do what, whether they will attract or they will do what, or they will repel. I told you already, this one is positive. Positive and negative will always do what, they will always attract, but negative and negative will always repel. So there's no need for you to write the negative in your um in your solving. E just indicating whether it will attract or it will do what, it will repel. That means divided by what, divided, what's our distance? Our distance is what, is 0.25, all this by what, 2. What's our final answer? So our final answer is what, our final answer is 28.8 newton. So if you solve it accordingly, you will get it. Helium nucleus has charge plus 2 electrons. You can see that here we were given electron, not microcoulomb. If you remember the other time that we were given just 2 microcoulomb, and I told you that micro means what, it's equivalent to what, 1 times 10 to the what, minus 6 coulomb, if you remember the other time. But in this place we are now given in electron. Now how we now calculate this in electron? Electron too is actually was different also. So a nucleus plus 10 electrons, where our electron, so we're already given our electron is equivalent to what, 1.6 times or minus 90 coulomb. Find the force exerted on one by the other when they are 30 nanometer apart. And number two, is the force repulsive or attractive? So even before we continue solving, this one we actually will detect. I told you that the other time that a boy and a boy will do what, they will repel, abi now, but a girl and a girl, they also do what, they will also repel. Right, so a girl and a girl will, they will do what, they will actually what, they will repel, but a boy and a girl will what, they will attract. Now we have positive 10 and also positive 10, they do what, they will repel. That means the answer for this B is what, it is repulsive. Are you getting the point at all? So okay, so our second question for today: helium nucleus has charge plus 2 electrons and a nucleon of plus 10 electrons, where the our electron is given to be 1.6 times 10 to the minus 90 coulomb. Find the force exerted on one by the other hand when they are given, when they are 3.0 was apart. So that's the distance. I told you already, whenever you are solving physics questions, the first thing you have to do what, you have to write out the parameters. That means we are given our charge. Our charge one is what, it is plus 2 electrons. Our charge two is what, is plus 10 electrons. And we are given our distance to be what, to be 3.0 nanometer. Now if you remember the first question that we are given what, 2 microcoulomb, 2 microcoulomb. Micro is what, 10 to the minus 6. If you can remember, when we now convert it in our first questions. But now we are now given in form of electrons. But we are already given that one electron is what? One electron is 1.6 times 10 to the what, or minus 19 coulomb. Hmm? That means now, and I told you already that what our constant K is what, is 9 times 10 to the what, minus 9, right? Which is our what, which is our constant. Now what is our formula? Our formula is what, is F is equal to what, KQ1 Q2 over what, over R square. What is our K, everybody? 9 times 10 is our what, 9, which is this, times, oh, what's our Q1? Our Q1 is what, it is 2. Our Q2 is what, is also 10 over what, what's uh our distance R? Yeah, this one is giving nano is what, 10 is power what, minus 9. Now since our nano is 10 to the minus 9, that's, it's going to be what, our R is what, 3 times 10 is what, minus 9. That's going to be what, 3 times 10 is what, minus 9. Now if we calculate everything, what will be your answer? So our answer is what, is 6 times 10 is what, 19 newton. But this is not our final formula, because what, our our answer is in form of electron. We have not converted this to this what, to this coulomb, because we are given in what, in electrons. In the former question we are given in coulomb, like in microcoulombs. So this one is now going to be what, times what, what's our electron? 1.6 times 10 to the power what, minus 19 coulomb. So what is our final answer? So our final formula is what, it is 9.6 newton. So this is our final formula, and we already answered this question already, that is it going to be, is the force going to be attractive or repulsive? I told you earlier the other time that if I have a boy and a girl here, and I have a boy and a boy, what do you think will happen to them? They will what? They will repel. A boy and boy can never marry each other, but a boy and a girl, they always attract. Why this one and this one we always repel? So I give you positive words and also positive. Positive we always repel positive. So is the first going to be positive or attractive? What's the answer? So before I solve this question, let me just say something to you guys. And now they can ask you guys to calculate your distance. Now to calculate that distance, you see that my f is equal to what? KQ1 Q2 over R square, right? That means that if I interchange, I will have what? My R square is equal to what? KQ1 Q2 over F, right? Just square both sides. If I square this side and also square this side, this square will cancel this. I will have my R is equal to what? Square root of KQ1 Q2 over F. So that's the distance. In case they ask you guys to calculate what's the distance. Now find the net force. Now how are you going to find the net force? I was telling you guys the other time that we have something that is this one is going to be attractive or repulsive. This one is what is going to be attractive, right? Attractive. That means this one will be attracted to this place, and while this guy is going to be what attracted to, it's not possible for we to have this one attracted to this place. Why? Because what? They will repel because they are the same charges. Like charges do what? They repel. Unlike charges attract. Thank you very much. Now, if we are going to do this one first, because we are asked to look for the net force, that is what the total force for everybody. That means I have to calculate when this one attracts to this one, and also when this also do what attract to this one. That means I'm going to have my what? My F is equal to what? KQ1 Q2 over R square, right? For who? For when our for when we have 3 microcoulomb and also was minus 5 microcoulomb. I told you guys that this our micro is what is 10 is power minus 6, right? That's it's going to be what's our key? Our key is 9 times 10 is power 9 is a constant, times what is our key one? Our key one is what? It is 3 times 10 is power minus 6, because I'm having what micro there, times what's our second one? My second one is what is 5, right? I told you not to put this negative. This negative is just showing that is in opposite direction. I get my point now. 5 times 10 is also what? Minus 6, right? Over what's our distance? Our distance here is what? It is 20 centimeter. Now, if I want to convert my centimeters to meter, I'm just going to divide by what? By 100. That means I'm converting 20 centimeters to what? To meter. That's going to be what? 0.2 meter, right? That's going to be 0.2. Now, what is your answer? So 0.2 square, yes. So our answer is going to be what? But it is just 3.375 Newton for this. Now you have to calculate like this when this also attract this. That means it's going to be my F is equal to, I have my minus 5 microcoulomb and also what? 8 microcoulomb. That's going to be what? 9 times 10 is power 9 times. Now for this, 5 times 10 by minus 6 times, for this 8 times 10 by what? Minus 6 over. Now my distance is 30 centimeter. That's going to be what? 0.3 meter, right? Because I'm converting from centimeters to meter. 0.3 all square. Now what is my answer? So the answer for this one is what? Is 4 Newton. Now to now calculate our net force. Our net force is now going to be what? It's going to be this 4 now minus this 3.3. Now do you know why we are actually minusing this? The main reason why is actually because of the fact that this one is attracted to this place, and whenever it's attracted to this place, it's going in this direction, right? And whenever this one is attracted, it's going, so that means they are going in opposite direction. That is why we minus it. That's going to 4 minus 3.3. So 4 minus 2. So 4 minus 3 point, that's going to be 0.625. So that is our answer. In the direction of what? In the direction of this x axis, in the positive side. Because this one is negative, this one is positive. Between negative and positive, what do we have? We have 0.625. So 0.625 in the direction of what? Of the x axis.